Hello and welcome to the second lesson of this course. Today we are going to consolidate the basics of Python programming language by going through more examples of basic programs. But before we do that, let's have a quick recap of what we learned last time, shall we? Last time I threw you in at the deep end of sorts by throwing a bunch of information at you, like how to print stuff using the print function, how to store information in variables, and how to take input from the user. And if you have never programmed before, it was probably a bit confusing. But do not worry, as that was my intention. As I said last time, when you're not sure about how something works in Python or any other programming language, you just gotta figure it out in one way or another, whether it's by thinking about the problem, googling for solution, or just typing it in the editor and trying to run it. So being confused about something is the quickest way to learn it. Not the easiest by any means, but the most effective, as it forces your brain to think critically about the knowledge you currently possess and how it can be used to arrive at the result you're aiming for. But hopefully, after playing around with all that information in your free time, you have a general idea of how you can write a basic Python program. So, what do we know right now? We know that our program is carried out sequentially, that is, line number 2 is going to be carried out after line number 1, line number 3 after line number 2, and so on and so forth until we reach the end of our program. We know the basics of printing in Python, using the print function. We know how to declare variables and store some information in them, whether that's numbers, whether that's text, or whether that's lists. We know how to comment in Python. We know how to do one-line comments and multi-line comments. And we know the basics of input using the input function. And now let's expand on those areas so that we fully understand what capabilities they offer. Let's start with the print function. Print is a function which takes some arguments, hello world in this case, and tries to print them in our standard output, which is our terminal in this case. It's actually quite sophisticated, as it will try to print out anything you tell it to. For example, if we were to create a variable, some text, and store some text in it, and then added it as a second argument for our print function, it would print it out together. Let's actually comment out the rest of our program so that it doesn't interfere. And run it again. And it printed out hello world and the insides of some text variable. If we change the data, however, in our variable to be a different type, for example, a number, let's do it right now, we would get different results depending on how we try to print our information. So if we run it right now, it will print out no problem, because we are giving some text as a second argument to our print function. But if we tried a plus, which would work with text, and try to run it, we will actually get an error. And if you read it, it says, type error, can only concatenate string, not int. That's because the plus operand in this situation tries to concatenate these two and pass them as a single argument. And Python sees that these two are different types, and therefore cannot concatenate them. So let's change it back to a comma. And that leads us nicely to the second topic of this lesson, and that is that all data has a dedicated type in Python and most other programming languages as well. On the lowest level, all data is stored in binary streams of ones and zeros, of course, but on a much higher level, programming language level, data is given a type so that we know what we are dealing with. We have already encountered several data types. First one, a string, which in turn is built from individual characters. A number, which can be integer or real number depending on how we define and use it, and a list, which is used to store other data in close proximity to one another. But why do we need data types? Well, we need them to dictate how data behaves in our system. If we want to add two numbers, Python will check that both entities used in our operation are indeed numbers, as here. It printed out 5, 2 plus 3. However, if one of them is a string, this operation will not be allowed, as addition is an operation that can be carried out only on numbers. So let's test it. Some text. If we run the program now, we will get an error. Again, it's a type error, such as we've seen a few minutes ago. Unsupported operand type, int plus string. We cannot use addition for two different types, for string and for integer. So let's change that back. Another way to think about it is, imagine if all data was considered one and the same. No distinction between numbers, letters, symbols, lists, and so on. You would then have to remember what each data point is referring to before carrying out further actions. And if you are wrong, which you would be quite likely, you would see very weird results. So it is a good thing to categorize our data into known and well-behaved types. So now that we know the difference between numbers and strings, and when they can be used together and when not, let's have a look at lists. Lists enable us to store multiple pieces of data in the same place. At least we see it in the same place. Where it is stored in memory is actually unknown to us and not relevant at this point. We can store information in a list by opening squared brackets and separating all data with commas, as seen here. Let's uncomment it actually and comment out the stuff we are not going to be needing. As can be seen here, the list is created with square brackets and all the information inside of it is separated by commas. But once it is stored, how do we actually access the information inside it? Well, we could print it all out, but what if we wanted a specific item in the list and not all the others? Well, actually we would use indexing to achieve it. Let's use the following diagram to explain how indexing works in Python. The way I like to think about it is that each item in a list is stored in its own little box and has an address associated with it. Same way that streets are indexed in real life. You have a street name, aka variable name in our code, and each house has a number, aka index in our code. But there is one major difference between real life and indexing of streets and lists in Python, and that is indexing of lists in Python starts with a 0. So if we wanted to access information in the box numbered 1, for example, this one, we would actually ask request information to request Python to access information in box with index number 0. If you wanted to access information in box number 1, number 2, we would request the box index number 1, and so on and so forth. In Python, indexing is done as well with square brackets, the same way we declare a list, and is done as such. We open and close square brackets, and inside we write an index, for example 0. Let's comment all of this out so that it doesn't affect our running of the program. And if we run the program, it will go to our list and it will access information stored in box index 0. And that is number 2. If we do list square brackets 1, it will go to our list and access information stored in box number 2, index number 1, and so on and so forth. And another note is that if you actually try to access the box that doesn't exist, for example 4, there's only 3 boxes in here, and try to run the program, we will actually get an error, an index out of range error. That's because we try to access a piece of memory that we don't have access to. Furthermore, there are other ways to index a list which is not very common in real life. One of such is to index a list from behind, not from point 0, but from the last element in a list. I'll use the following diagram to illustrate it. And let's delete the old one. So we know that the first element in our list is indexed 0, but the last element in our list is indexed -1, and we can go backwards from there. So if we try to print the last element in our list, regardless of how long it is, we would just request it as such. And now let's try to run it. We get an error because Python doesn't understand what this is, so let's comment it out and try again. And as we expected, we got the last element of our list. If we try -2, we are expecting hello, because now we are indexing from the other way around. And the same way as in previous example, if we try to index too far, for example -5, which would go -1, -2, -3, and -5 back into the memory which we don't have access to, we would get a list index out of range error. Another very useful way to index information inside a list is using a double dot notation. And that is used when we want to get several items close together from a list, but not all of them. And that would be done by doing something like this. This allowed us to get all the data, all the boxes, starting from 0 and before 2. So 0, 1, and doesn't include 2. If you wanted to include box index number 2, we would have to use ... 3. Unlike in previous two examples, if we try to index outside of memory, it will actually not cause a problem. Because what double dot means is it's basically saying, go as far as you can, and once you reach the end, stop. And that is everything you need to know at this stage about indexing information in a list. Now on to the last two fundamental Lego blocks of R programming. That is commenting and inputting data from standard input. Again, in this case, that's our terminal. What we need to know about commenting at this stage. Commenting is a tool used to make our code more readable. The more you learn to code, the more complicated code you produce, and eventually you will reach a point where reading the code to understand what it does is simply too time-consuming. Then you would add a comment explaining in plain English what this code does, and assuming it was written by a person who understands what they're doing, we can trust that the comment is an accurate representation of the algorithm in question. If you want to write a short comment just explaining what your function does, you would use a hashtag, and if you want to write a longer comment, for example, at the start of your program explaining what the whole file does, you would use a multi-line comment. A cool shortcut in Atom, and I'm sure it's similar in other text editors, is if you select a piece of code and press Command/, it will actually comment everything you've selected, and you can uncomment everything the same way. That will save you a bit of time in the future. Now on to inputting data. There are many different ways to input data, such as read information from files, receive it through a WebSocket, and others. But at this stage, we are really only concerned with receiving basic data from the terminal. To do so, we can use our input function. Let's actually uncomment that. We can use our input function, which will prompt the user to enter some data, some text in the terminal, and then we can store it in a variable for further use. At this point, it's important to note that regardless of what the person enters in the terminal, it will be treated as text, and therefore stored in our variable. The data type of information stored in our variable will be a string. That concludes the basics of Python programming language, and the next time we will learn about implementing conditional logic into our programs. See you then.